Let's apply the techniques that we learned about geometric power series and find a power series for 1 over 7 minus x centered at c equals 1, and then we're going to talk about the interval of convergence. Well, let's get to it. So I guess one thing we need to do is we need to go ahead and write that that's true. 1 over 1 minus x is the infinite series from 0 to infinity of x to the n. And then in general, if I had like an a here, that's ax to the n. So we'll go ahead and kind of write that for reference. So what we need to do here is we need to get something like this into something that looks like that. I mean, realistically, we're trying to get a times r to the n. So really, ultimately, you're trying to get some sort of r and some sort of a out of this. But we have to algebraically manipulate. Really, the big thing here is just algebra. So what I'm going to do is I'm going to say, okay, I've got 1 over 7 minus x. Now it needs to be centered at c equals 1. So ultimately, I don't need just an x, I need x minus 1. But here's the thing, I don't just get x minus 1 for free, right? You just can't just write a 1 in there. That's mathematically invalid. We have to balance the equation. So ultimately, if you look at this negative, it's actually negative x plus 1. Right, if you multiplied this out, you get 7 minus x plus 1 minus 1. So now we have a balanced equation because ultimately those 1's would have canceled each other out. So then what we can do is we can simplify what we have. We can say, okay, that's 1 over 6 minus x minus 1. Okay, but here's the thing. We're trying to get it into this form. That 1 is fixed. A and r are just kind of parameters. We can play around with them, but we can't play around with this. This has to be a 1. So how do we get this to become a 1? Well, the easiest way to do that is just to factor that number out. So now I have, if I pull out a 6, I have 1 minus x minus 1 over 6. And if you multiply that through, you'd see you'd get the same thing here. But again, there's no factored number here. So the easiest way to do this is to rewrite this again as a 1/6 on top and now I have 1/6 over 1 minus x minus 1 over 6. Yikes. Which tells me that a is 1/6 and r is x minus 1 over 6. Which allows me then to rewrite this as a power series with these parameters. So my power series is n equal 0 to infinity of 1/6 times x minus 1 over 6 to the n, because that's a and that's r, right? So we have it set up. Now that that's set up, we say, okay, this is my power series centered at c equals 1. Well, that's great. What's my interval of convergence? Okay, well, if I do my interval of convergence, what I have to do is I have to say, all right, this thing has to be less than or equal to 1. I have to say x minus 1 over 6 less than or equal to 1. Now, I can distribute the absolute values here. I can say x minus 1 on top, absolute value of 6 on the bottom. But you know that the absolute value of 6 is just 6. And then if we multiply both sides by 6, we get that. Now, the easiest way to solve this type of problem is to set it up as like a double inequality, because if the magnitude is less than 6, what that's telling you is that it's greater than negative 6, but it's less than positive 6. That's the easiest way to do that. Why is that helpful? Because then if I just add 1 to both sides, I get negative 5 less than x less than 7. So my interval of convergence is negative 5 to positive 7. Now, this is a geometric series, so we don't really have to check endpoint convergence. But if you wanted to check endpoint convergence here, if you plug in negative 5, you're going to get a negative 6 over positive 6. So you're going to get a negative 1 to the n. That's going to be an alternating series, but this term here doesn't decrease to 0 monotonically, so it would fail the alternating series test. It would diverge. This would actually fail the nth term test for divergence because the limit would not be 0. And then if you did with 7, you'd get 6 over 6 to the n. So that's just 1 to the n. So that really just disappears because 1 to a power is just 1. So just kind of evaporate. And so you'd be summing up 1/6 an infinite number of times. Well, obviously that's going to push off to infinity. It would fail the nth term test for divergence as well. So you have this power series with this interval of convergence. Sorry, hopefully you can see that. This power series, this interval of convergence for this particular problem.